So we're going to graph these two functions. One's an exponential function and one is a logarithmic function, and we're going to use shifts and transformations. So question number one, it's an exponential function because you can see x is in an exponent. So the base graph here is 4 to the x. 4 to the x roughly looks like this. I'm going to do it very lightly here. Exponential functions always go through 0, 1 because anything to the 0 is 1. Has an asymptote, a horizontal asymptote on the left at y equals 0, and then increases rather quickly. So that's the shape of an exponential function. This would be y equals 4 to the x. Now I did that very lightly because this is now transformations of 4 to the x. So we're just going to take that light yellow graph and transform it how this says. So the first thing I'm going to do is rewrite this a little bit. I'm going to make it negative 4x to the x minus 3. Just reorder it so the exponential part comes first. And then I'm going to use all of my knowledge of transformations. So when you have a negative out in front of the function, it means flip on the x. Minus 3, which is inside the function, that's left and right. The minus means right. And plus 3 outside of the function is up and down. Plus means up 3. So this is all stuff you've studied before. We're just doing it with an exponential function. So now I'm going to do this in the order that it appeared. So first of all, my flip on the x. I'm going to do that very lightly. So if it's on the x, now it will go through negative 1 here. And other than that, there we go. And now I'm going to shift it. And I'm going to shift it from this key point, the one that started at 0, 1, right 3 and up 3. So I'm going to take that point and move it right 1, 2, 3, and up 3. 1, 2, 3. So now it's at 3, 2. It's very simple. And then I'm going to redraw this. The one thing is, here's the big point. The horizontal asymptote should be exactly or close to 1 above it, and then just redraw this. And that red graph then is the final graph. So it is pretty easy. If you do a couple of these for practice, it comes really quickly because you've done them before. So the next one is this natural log function, which is log base e. And this one is actually very similar to the one we just did. So it has all the transformations in it, but first of all, it's a log. So the log function, the ln function, or log base e, looks like this. Log functions always go through 1, 0. So opposite the exponential, which was 0, 1. And it looks like there's a vertical asymptote at x equals 0. And then it really flattens out. It still keeps going up, but it goes up very, very slowly. So that's your log graph, your basic log graph. So now we're going to do the transformations. A negative out in front, again, means flip on x, just like it does for all other functions, just like the exponential function. So I'm going to do that right now. I'm going to flip it on the x. So since this 1, 0 point is on the x, that's not going to change. So this little tail down here on the left is just going to be the tail on the right now. And then the other part of it above the x-axis is now going to be below. So that's the flipped part. So that's the one I'm going to shift. How am I going to shift it? Well, plus 3 on the inside means left 3. And minus 6 on the outside means down 6. So from this point, the 1, 0, I'm going to shift the flipped graph left 3, 1, 2, 3, and down 6. 1, 2, 3, 4, 5, 6. And I'm going to retrace this graph. Remember, this This tail here should not be more than 1 to the left of that. So, oh, that's bad. I'm going to do it like this. And then there you have it. So remember, this point was, if I ask you to mark these points, this new point here that was started here is now at 3, 2. That's this point. And this point that started at 1, 0 is now at -2, -6. So that's how you graph these functions. Again, it's easy. Just practice it.